31.5 Resistive Welding Definition. Resistance welding covers a number of processes in which the heat necessary is produced by electrical current being passed through the materials being welded. Spot welding, to metal sheets are clamped together and current is sent through the metal sheets. Typically, spot welds are characterized by a small, round discoloration and depression. Spot welding, this is called the weld nugget. They are used extensively in industry, especially automotive manufacture. Spot welding. Testing spot welds. 4 types of spot weld tests. Tension test. Most common because it is cheap and easy. Cross-tension test. Twist test. Peel test. Commonly used for thin sheets. Both are good at finding flaws, cracks and porosity in the weld area. Testing spot welds. Seam welding. Resistance seam welding are SW uses 2 wheels instead of 2 electrode probes to create a long single weld. The 2 sheets of metal are passed through the wheels while electrical current is applied. Seam welding. High frequency resistance welding. This is similar to seam welding except high electrical frequency up to 450 kHz is used. Typically it is used to create the welded tubing. Projection welding. Resistance projection welding RPW. One of the metal sheets have 1 or more projections embossed into it and causes weld nuggets to form at those points. After enough heat is created, then the sheets are pressed together. Projection welding. Flash welding. Flash welding FW. This is sometimes referred to as flash, but welding heat is generated from the arc as the 2 pieces make contact. When sufficient heat is created, the ends of the 2 pieces of metal are pressed together. Stub welding. Stub welding. Southwest. A small part, typically a threaded rod, hanger or handle, acts as one of the electrodes. The metal sheet acts as the other electrode, and after enough heat is generated, the stub is pressed until a sufficient weld is created. Percussion welding. Percussion welding uses a capacitor to provide electrical current instead of a transformer. The advantage is that localized heat is created, making this type of welding ideal for parts that are next to heat-sensitive areas such as electronic assemblies.